The objective of this exercise is to create a forecasting of PD over time using macroeconomic variables. More importantly, it will be to simulate, in the end, likely PD trajectories over time. This exercise can help to stress the PD parameter. Recent events such as the pandemic, climate change, energy crisis, Ukraine-Russia war, and recently the escalation between Israel and Palestine are generating uncertainty. Lack of security, distrust about the future of the business, inability to predict, and paralysis in financial decisions. Therefore, it's important to create new solutions that respond to this time of crisis. At Firma Risk, we have created a training offer focused on artificial intelligence and quantum computing. We believe that both AI and quantum computing will be able to solve complex problems. And although quantum computing is an experimental stage, there is considerable activity and investment around its development, such as the government of the United States, Germany, and China, banks like JP Morgan and Goldman Sachs, technological companies like IBM, which, by the way, is expected to have a computer with just over 1,000 qubits this year. It's important to mention that quantum computers have already proven to handle voluminous information and solve complex problems very quickly. It is clear that this quantum process is already underway and will advance by leaps and bounds. It's therefore important for financial risk professionals to know the mathematical aspects behind quantum computing, quantum mechanics itself, and programming languages. Our paper stress testing exercise are more important for the survival of financial institutions. They include satellite models, scenario analysis, projection, and the availability of information that is absolutely important to perform the stress testing. This document is named COVID-19 and Climate Change in Credit Risk, the next generation of modeling the PD. The objective is create a stressed PD and creating forecasting of the PD using traditional models, econometric models, and machine learning models too. This is the data that we will use. Is data of a company with variables, macroeconomical variables. The frequency of the information has become a problem having models with quarterly data. Could be a drawback to know the direction of the banks in times of crisis. For example, the disruption of supply chains during the COVID-19 caused the GDP of many countries to fall by as such as 18 in one quarter was absolutely complex to modeling. Daily information could be a solution, although in many countries it may not be affordable. From my point of view, I think we will have to work on it. Let's look at our exercise, and we can see the following table with information from the credit risk PD and daily or weekly macroeconomic variables from January 2020 to May 2021. The frequency is daily, and this is the plot of the PD. You can see that just in April in 2020, the PD rises abruptly due to the brutal fall of the GDP produced by the COVID in this date. After that, there is a sharp fall and then a softer fall. The first variable macroeconomic daily, or in this case weekly, that we use is just the weekly economic index. It's an index of 10 indicators of real economic activity scale to align with the 4-quarter GDP growth rate. And it represents the common components of the series covering consumer behavior, the labor market, and production. We can see this graph. The graph shows the weekly economic index falling in April, as you can see, obviously for the COVID-19. After this start to grow up, as you can see. The next is very interesting, is named Economic Policy Uncertainty Index, and this index reflects the relative frequency of an own country, in this case United States, that reflect newspaper articles that contain a trio of terms that is economy, just policy, and uncertainty. It shows the behavior very similar to the PD. A significant rise in April 2020, but as you can see, a lot of volatility all the time. The next is the Standard & Poor's 500 that have this fall and start to grow. Well, the next is very interesting. The US High Yield Index is a US dollar denominated index which measures the performance of high yield debt issued by corporations that are domiciliated not just in United States but in Canada too. It's a thermometer of the economy and can serve as a trigger to prevent with days a potential crisis. Show the deficiencies during the crisis in 2018. Very important, and as you can see, start to grow out before April, and alert that something very bad is coming. The next is the 3M LIBOR, 3 months LIBOR rate. The 3 months LIBOR rate is not used now, is the SOFR now, the new rates for the transition to LIBOR rates. And as you can see, the drop in the rate is due to the easy quantum monetary policy that apply the Fed, and in Europe is the same by the central bank European. After we have seen the inflation to 10 years, this plot show that the signs of an uninterrupted rise and has continued to be unstoppable to date. I mean, the inflation continue growing, and it's a very big issue now in the monetary policy. Other is the job posting of Indeed in the United States, which is a variable and similar to the employment rate. We can see that the job posting fall obviously in the months of the starting to COVID, also for the reason that the people are living in the houses, and it shows after a growth. It's a good sign of the economy in this moment. Okay, this is other about the COVID-19. This is the total cases of COVID-19 we have here the new cases of COVID-19 that show the waves that start to see during these very hard times. This is the total deaths, the new deaths like waves 2, and this variable is the hospitalized patients for the COVID-19. And here, the people vaccinated with the COVID-19. That start approximately in the 2021 January. Here, the new vaccination is smoothed per million. And it is a very important index named stringency index. It's a composite measure based on 9 response indicators, including school closures, workplace closures, travel bans, and have a value from 0 to 100. And you can see that this stringency index is very high in April and continue during the COVID. They start to have a fall maybe in April 2021. Okay, this is a correlation metrics between all the variables, and see the relation is very important for the modeling. See the pairwise relation, and this is most nice pair plot that you can see. It's a pairwise scatter plot. It's a type of visualization that shows the relationship between all pairs of variables in a data sets, and we can see relation absolutely interesting between all the variables that we have, because have macroeconomic variables, but we have 2 COVID related variables. Okay, now we're going to create a regression model without having checked if the variables are stationary or not. It's a simple exercise that maybe help to determine the relationship of the PD with the macroeconomic variables. In this sense, for example, we say that the PD is explained by the way the inflation, Standard & Poor's, high yield index, LIBOR, job posting, and the variables of the COVID-19. We can see in the results that have impressive R square of 19%. And maybe we are very happy to obtain the result. However, if we see the Durbin-Watson, that is 55%, we can use a rule of thumb that we can say that the regression is spurious if the Durbin-Watson is less than the R square. In this sense, we have a problem with this data. Now we can start to estimate if the variables are stationary or not. And in this sense, we use a very powerful test named Augmented Dickey Fuller. I think it's very nice to determine if we see a stationary time series or not. And there are others, but I think it is very good. We can see, for example, with the first variables that found that the variables are non-stationary, including this is the PD, the weight is non-stationary, the Standard & Poor's is non-stationary too, high yield index non-stationary, and all the variables are non-stationary. And then we have a problem because we can use a regression or other model because the condition is that the time series be stationary. Okay, a time series whose statistical properties change over time is called a non-stationary time series. Thus, a time series with a trend or seasonality is non-stationary in nature. However, if the series are non-stationary, we cannot use them. So we can differentiate them with the same order in case the first difference, and we can see that some ones of the series are now stationary. Differentiate with one lag the series and convert to stationary. However, not everyone. For example, he are stationary, but we found that the job posting is non-stationary. Okay, if we want to work with all together, we need the condition that everyone is stationary. Now we can use other differencing, the second differencing, with two lags. And in this sense, we can see that everyone is stationary. And now with two lags, we can use perfectly in any model, in any econometrical model that we can use. Okay, other important test, if we can use all the time series, is the cointegration test. This verify that the time series are cointegrated, and we can apply a Johansson cointegration test, and it turns out that the series are cointegrated and we can use them together in a model. This is the advantage to use this. And we found that effectively our cointegration, so the cointegration test is positive, and are cointegrated the time series, and we can use. The next step is, for example, apply an econometrical model, for example, the vector autoregression BVAR. This is maybe the most common used in a banks. The vector autoregression is very easy to implement and have good properties. However, we can use other advanced models, just like machine learning that we will see in a few moments. Okay, to use the BVAR model correctly, it's important to determine what is the difference, or what is the lag or the order P that we need to use to obtain the best performance of the model. Just to say too that the BVAR capture the relationship, the PD between multiple macroeconomic variables, and as they change over time. The selection of the order of P is, in this case, is using the lowest Akaike information criterion, AIC. It is a mathematical method for evaluating how well a model fits the data and it was generated from. We can see in this case that the value more small of the Akaike information criterion is just the lag 2. In this order, we can use the order P same or equal 2. Okay, now we have the summary of regression results. applied the BVAR using the method OLS, and we have the coefficients, the standard error, the t-stat, probabilities, etc. And this is the equation because we obtain a set of equations. The first is of the PD and the economical, macroeconomical variables and COVID variables too. We can see the coefficients of the way, the Standard & Poor's 500, the equation of high yield index, the LIBOR 3 months, inflation 10 years, job posting, new cases smoothed per millions of COVID-19, and the other COVID-19 variables. Okay, here are the correlations, and it's very important to review if exists a problem named autocorrelation serial. Autocorrelation serial could be a real problem in the models, and we need to review if exists. In this order, we use the Durbin-Watson statistic. It's a test statistic to detect autocorrelation in the residuals, and a value of this Durbin-Watson equal to indicates that there is not autocorrelation, and we can see that don't have autocorrelation. All the numbers are close to 2. The next step is create a forecasting. A forecasting in this sense, we can see in the 2 months if we can use this model to create correct forecasting of the PD. We have created a training and validation sample, and the validation sample is approximately 45 days. Okay, this is the result of the forecast. We use this instruction in the code made in Python, named forecast, and we can see here the result of the adjust to these numbers first, and then the projection of the PD and the other variables. Okay, we can see here in this that the PD forecast, it's similar, have the same trend to the PD real. The PD real is the orange line that, as you can see, and the blue is the PD forecast. Okay, it's not so bad, but the other variables are not good. The results. The way, for example, have the forecast, it's absolutely different. The way is grow and it is have fall, and the Standard & Poor's a little similar, and other variables, as we can see, not so adjusted or not so fitting as we can wait. Okay, now we are now going to look at some time series on climate change. We add a climate change time series to the model. Why? Because it's now an absolutely important topic. If we can add climate change, we can create a relationship between the climate change and the great risk. The most common way is through the probability of default. Now we have here the same data, and as you can see, we have other time series variables about the emissions, the CO2 emissions, and we can see, we will see the graph. The first is the CO2 emissions variations of power sectors. We can see a reduction in emission to the beginning of the pandemic, and then a gradual growth. This is the emission of the power sector, and this variable is the variation about the industry sector, and have the same, start to reduce the emissions during the pandemic and start to grow during the next months. This is a little strange for me, the CO2 emissions variation of residential sector. Here we can see a surprising effect. During the pandemic and confinement, the emission levels reduced significantly, particularly in this month of July to September approximately. The other is the domestic aviation. The domestic aviation, the airlines did not fly during the pandemic, and the drastic drop in emission is important, as you can see. Okay, well, with these variables, we can create now other kind of model, a machine learning model, particularly a deep learning model. This kind of model, named long short-term memory multivariate, is an artificial recurrent neural model architecture, and it's absolutely powerful. It's used in a lot of ways. We can use this to forecasting time series. I think is absolutely good. This long short-term memory is work with neural networks that recurrent work between them, as we can see. I used to work with these models, or try to use all the time something, and particularly techniques to avoid, for example, the overfit that is very common in these models and be dangerous to modeling. This is a very important thing to avoid, the overfitting. Okay, in this sense, we try the data, scaling, doing the engineering filtering, that is very important. Here, create also the sample data, create a test and training data is very important too. And we are using in this exercise Keras and TensorFlow. Okay. After we use other like a torch libraries that are very good too. Okay, the neural network, long short-term memory, have 64 neural networks in the first layer. In the second layer, I have 64, and then have this layer named dropout. Dropout is very important. Dropout layer is a mask that nullifies the contribution of some neurons toward the next layer and leaves and modify all others. And then with dropout, we can accomplish better prediction exactness. Is very good. In other words, one neurons work and other not work. And it produces that the neurons that are working work better. This is a little the idea. We use for this Adam, it's an important optimization method. I think is very good, and the loss is the mean square error too. And we use in order to treat with the with avoid to overfitting. Another thing, for example, the early stopping is very good. Is a form or regularization used to avoid overfitting when training a learning with an iterative method. Others are reduce learning rate on plateau, reduce learning rate when a metric has stopped improving too. Okay, and then we use here 30 epochs. Epochs try to train the model starting with the data to the end of the output. So, I mean with all the model and all the data, and are in this case 30 epochs, and we can see the results. Okay, we have the predictions, the performance of predictions. Later we will see, and this is the prediction train that we have created. In this plot, we can see the graph that the observed PD fits, I think, very well to the estimated PD. And the black line after these points in green are the real PD. I mean, this is the real PD, and the predictor PD is very close to the real PD. I think it's a very good fit, and the projection is good. Now the projection is just 1.5 months, and okay, I think it's a good projection, as we can see. Other tool very important is the Bayesian bar. This is other econometric model. It is not a machine learning model. It's a econometrical model. The Bayesian bar, it's the Bayesian vector autoregression, okay, and use Bayesian methods to estimate a vector autoregression bar model. BVAR differs with standard bar models in that the model parameters are treated as random variables, not like a fixed variables, okay? And with the prior probabilities rather than the fixed values, we can infer with these prior probabilities, apply Bayes' theorem with the data, use, for example, a method like MCMC, Monte Carlo Markov chain, and we can obtain the posterior probabilities of these parameters. We can see the same, that we are using the same data. It's an exercise the bar, in this case, is the Bayesian bar. And here, is very nice, this instruction that put the architecture that we are using to create use the prior probabilities and obtain posterior probabilities using the Bayes theorem and the MCMC approach. Okay, here is the results. The results are coefficients. However, because we are using a Bayesian bar, we can obtain scenarios too, and this is interesting. We can see here this plot that show the coefficient, and the lines mean the range can the coefficient have. It's interesting, this graph, and here the plot trace, and the distributions. For the data that are very high, for the reason we can see the distribution here. This is the trace, and the trace we can, or the idea is that be stationary. If it's non-stationary, don't works the Bayesian vector autoregression. Okay, we create a forecast, but not just a forecast, because we are using probabilities. It's very important. We can create scenarios too, and this is the use of these models. We first can create in an expert way a prior probabilities and obtain a posterior probabilities. In this sense, the forecast that we have in the next days are these. We can see the PD, the way that we have. It is the LIBOR of 3 months, and here the inflation rate. And well, it's a little, don't see very good because I are a little late, and we can see a different scenarios to the probability of default, other scenarios to the way, and in this sense. In the way, honestly, is I think is not good the fit, like yes, in the other variables that fit good and create scenarios, and with this, in this sense, we can use this to create a scenario analysis and stress testing. This is the idea, to use the Bayesian approach. Now we use other interesting model named Bayesian long short-term memory. Bayesian inference, as we see, permit the quantification of the uncertainty. For this reason, is very important, because I told before that the problem now is measure the uncertainty. No? During these months, there are absolutely uncertainty, and in this sense, this is a tool interested to measure and quantification the uncertainty, and thus enable to development of robust machine learning models. Maybe it's a little more complex because we are using probabilities, and in this sense, maybe the time to obtain results is delay a lot. The core idea of the parameter optimization based on Bayesian theory is to treat the long short-term memory as a Bayesian model. I think it's like the Bayesian bar is the same idea. Place a prior distribution on the network weights and bias parameters of long short-term memory, and then use variational inference to infer the posterior distribution of the parameters given the data. The same idea of the Bayesian bar, but here with machine learning. Okay, I had that the financial uncertainty is more common in these times, and therefore we need models such as this. Probabilistic reasoning is a form of knowledge representation in which the concept of probability is used to indicate the degree of uncertainty in knowledge. Okay, well, the idea in the Bayesian neural networks is that rather than having deterministic weights, we can sample them for a probability distribution and then optimize these distribution parameters. Here we show the architecture that we can use is a unidirectional long short-term memory with two stacked layers and 128 hidden units. This is the encoder, decoder stage, and the predictor stage just with one fully connected output layer. Okay, now we can use Torch. Torch is other very useful and very great library of machine learning, and in this case we use the Bayesian long short-term memory. It's absolutely good from my point of view. And then with this the idea is finally create a probability distribution, okay, of the weights and the bias too, and I mean of all the parameters that are in the neural network. And it's important here to comment that we use the dropout. The dropout, not like before in the other model, in the sense that we need to improve the results. In this sense, the dropout probability is to create samples and obtain different parameters. I mean, in short, the other long short-term memory, we use the dropout to improve the parameters, and this use the dropout to create samples, okay, and with the samples create a lot of predictions and create a lot of parameters. This is the idea behind this. Okay, in this sense, we train the Bayesian, in this case, with 300 epochs, and then evaluating the model performance. And as you can see, we have this beautiful graph of plot lie. In the graph, we can see the green line, okay, that shows the time series of real values. Okay, the blue line is the training prediction, and the red line will be the test prediction. I mean the forecasting. And it's good, so I think it's very good. It's not bad. The forecasting result is well adjusted to the real values. However, it's important to say that the objective of stress testing is not only to make projections and forecasting. It's important to create scenarios, okay? But we can use this absolutely good model to create scenarios like the Bayesian vector autoregression. Okay, scenarios can be macroeconomic or should be macroeconomic, but we can also create scenarios with the Bayesian model. Why? Because we are creating with a technique of dropout that I comment that we can have a lot of parameters, and these scenarios are very good, are related with the model. Okay, yes, we can add macroeconomic scenarios too. It's important to comment, and the objective is obtain confidence interval with the PD estimate. In this sense, we measure the uncertainty or uncertainty quantification. The fact that the stochastic dropouts that I told are applied after each long short-term memory layer in the Bayesian long short-term memory enables users to interpret the model outputs as a random samples from the posterior distribution of the target variable. And this implies that by running multiple experiments and prediction can approximate parameters of the posterior distribution, namely the mean and the variance. Okay, and in this sense we can create confidence intervals. In the example we use the 99 confidence intervals. Okay, this is the code to create the lower bound and upper bound related to the PD mean and the PD standard deviation. Okay, and in this sense, we have this graph. In the graph, we can see the 99% of confidence intervals. The blue is the upper, and the red is the lower. And it can be seen that the actual values remain in the confidence interval from January 21 to May 21. During the period of the test. This quantification of uncertainty can be used in two areas: in the quantification of model risk and in the stress testing scenarios. Okay, to evaluating the uncertainty, we can review if all the what is the number of the cases that are between these intervals. It will be a great exercise, and in this sense, with this interval confidence of 99, the proportion of points contained within 99 confidence interval is 96.42, no? 0.42%. I think it's absolutely good. It's good. This model is I think is powerful. Okay, this is then the model. Here we have the test uncertainty and the graph again. I hope you like the video. The next week we will upload the second part of this video. It will be even more interesting. We will test again the powerful long short-term memory model against now the quantum long short-term memory. We will see if the quantum enhancement could improve the estimation of traditional deep learning. This exercise is part of 3 courses: Quantum Grade Risk, IFRS 9 Grade Risk Modeling 2, and Stress Testing Quantum. Check our training offer in this link, and see you soon, and thank you.